large, I don't need them at all. I just use a z-score instead. So z-scores live at the bottom of a t-score chart. Now, if you use the z-score chart, you're going to get 2.575 because it's not as precise on these kind of things. This one goes out truly 3 places. That one they had an average. So what do I put here?
Negative.
Yep, and then here? Yep. And then a shade there and a shade there. No, definitely not. When would I reject the null? The guy who thinks it equals, the guy who thinks it's in here. If I'm out here, then I would reject it. That's why we call it the rejection region. It's the region that I would get into to reject the null. Point to it.
The rejection region?
I can't. There. The rejection region is in 2 parts because it's a 2-tailed test.
So if it was one tail, the part that's not shaped? Or is it always the part that's shaped? That would be...
It's always the part that's shaped. And it's got to be in the tail. So again, at the end of my hypothesis test, I can reject the null or I can fail to reject the null. What does the null always have? Some kind of what? The null has to be the one that always has equal sign. So the null is always going to be the one that thinks it's in here somewhere. That thinks it's equal to the 24.81. So my rejection region is always going to be away from there. When can I reject the null? When it's so far away from what the null thinks that it looks like he's wrong. You think that? Look at this. You're wrong. That's another way to say it. Summarize the hypothesis test. So how do I say this in words? Where do my sample has to go in order to reject the null? How do I get in here, for example? If my z-star is what? How do I get in there? My z-star has to be less than negative 2.576. Or how do we get in here? Greater than positive 2.576. And if we get in there, what can I do? What I just told you. Reject the null. Support the high. And in a sense, I just wrote the same thing twice. Right? If I say that guy's wrong, then I'm saying the other guy who has the opposite opinion is right. If I say you're half as old as I am, and then I say I'm twice as old as you, I just said the same damn thing twice. Right? There's 2 different perspectives. So either I reject the null, support the high, or I fail to reject the null, fail to support the high. Okay, a lot of kids. And I just wish, I know you guys can get buried. There's 5 steps. They're all a little freaky. They're a little bit used to something we're used to, but they're also a little bit different, right? But if you just hold on to the basic idea, one guy thinks it's in here. So if I get really far away from that, I can say that guy is wrong. That really is it. That's the how far away something is what's evidence in this case. Okay. So now that I've set up what far enough away is, the next thing I'm going to definitely do is see how far away I got. So what do I know from the sample? What was the sample mean? No. Yeah, 24.81 was what it was in 1990 for everybody. The sample I took, I got 25.29. Okay. What was the standard deviation that I know? So then what do I have to do with that? Good, I'm going to change it. Divided by square root of, which is? There you go. This is the step that is definitely oldest. Yeah.
When we're like, say we're doing a problem like this on a quiz, would it be given to us to like X bar equals standard, or we would just?
It would be just like this. exactly like this.
Okay.
I know that's a sample mean because it came from the sample we took. Right? We take a sample and we see this. All right, that's a sample mean. You have to be able to interpret the situation I give you. Yeah. And what? Anybody do that yet for me? What do you guys get for this? 0.194. Okay, I like it. I got verification. Guys. So now I do the Z star. It doesn't change. What's my data? What did we find? That's first. No, what is this? No. What is that? That's the spread. Where does it go in the Z-score formula? On the bottom. Yeah, what's the data we found when we took our sample? 25.29. What is it supposedly? 24.81. So we're assuming that the number that's up here, we're going to say, okay, assuming that is the middle. Look what we just did. That's the idea. Yes.
You say what's the data? Isn't it always going to be only type of data? Wouldn't it always be like means? Like
Nope.
sample?
We're going to do percentages today. Yeah. Oh shit. So you guys are going to think the Z-score formula changes, and weird ass Jeff is going to be like, nope, it didn't change. You're all going to be, there's some P's in there now. I don't give a shit. It's our data minus what the middle is divided by what the spread is. Always. And what do you guys get for that? Who? 2.47. Okay. Did we make it far enough away? Nope. That's pretty far away, but shit, man, we did not make it far enough away. We're right there. We didn't make it far enough away. The hoe dude could be right. Because we're in the middle part. We didn't make it far enough away to make the middle part look like it's wrong. Yes?
So, didn't it make it inside of where it's not shaded?
Of course.
So,
Yes.
didn't you say that if it makes it in the shaded area, then you reject it?
Exactly. Yeah. So I haven't said anything against that. We didn't make it far enough away, so did we reject the null? No, we failed. We didn't make it in there. Yeah. Yeah. So we failed. You're right. Exactly what you just said is right. We did not make it in the shaded part. We didn't make it far enough away. So we can't say the null dude is wrong. Yes.
Is the Z-star formula X bar minus X over
No.
sample?
So officially it's this.
Okay, so it's the mu X bar that I got wrong. But we're always gonna know that that is always gonna be what the problem initially told us.
Yeah. We're fighting against it being this.
Okay.
So we're going to assume that it's this and try to find evidence that it isn't. And again, this defines what far enough away is. So if 24.81 really is the middle, then a sample I get should be in here. Did we get it in here? Yep. So that's why it doesn't say that it is 24.8, but it definitely is not evidence that it ain't. We did get what we're considering to be close. We got here. So we got in there. So we got close to it, which is what we expect a sample to do if that really is the real mean. Now, in general, I wouldn't say that's close. But for this test, it had to get this far away, so we didn't get far away enough. So what can I say right here? We already said it. What did I do? Did I reject the null? Nope, I failed to reject the null. And I failed to support the high. So then your last step is to blow one of these statements up, to write your conclusion. What was my claim? What was the claim that was made? The high. So I'm going to use this language, not that language. So how does fail? We failed, so we have not. Bless you. Found sufficient she's allergic to. Conclusions. We have not found sufficient evidence to support the claim that plagiarize, that the average age for women at the time of birth of the first child has changed, that the average age of women at first birth, that sounds so weird, has changed. We have not found sufficient evidence to support the claim that the average age of women at first birth has changed. I know that sounds crazy, but did we make it far enough away to say that it looks like it's not this, that it looks like it's changed? Nope. So that's what we just said. We didn't find evidence to say that it changed. Yes?
Other than obviously using the correct terminology, failure to reject and failure to support, what we write down, is there a little bit of leeway?
Of course. Always is.
Because
And
these are just
you
so
can
wordy.
experiment to see how much leeway you get.
That's what that's.
All right, this is amazing. Oh, might not. Anyway, too bad for us. You guys try this one out. We're not going to get as far as I needed to, but
What about the
oh,
yeah.
p-value. What's our z-score?
2.47.
2.47. Remember, this is a two-tailed test, so you find out what's in the area of 2.47, and then you double it. So let me draw a little picture down. So I got my 2.47. I want to see what that area is here. And then I double. Yes?
My question earlier about this was like, how do you, I'm just confused for like a one-tail test, how do you know which direction to go into, like
If your z-score is negative, you just get what the chart says, because then the area in the tail will be the area below. If your z-score is positive, you're going to have to do one minus that.
okay.
That's it. That's it. Okay. We know how to do that.
Because sometimes, that's why you said like z-scores, because they, like in certain formulas it says plus or minus already, you would be giving it a negative or positive.
Confidence intervals are built on going up and down. So they have a plus or minus in their equation. That has nothing to do with this. This is finding the area and the tail of a z-score. And that was what we did a ton of when we first got that z-score check. Yeah. So that idea hasn't changed. It can't change. What do you guys get? Anybody got that? Do it again. Almost. One minus that.
Oh yeah, 0.006.
I love you guys. When you look up 2.47 in the z-score chart, do you get this area?
No.
What do you always get when you look at that z-score?
Below it.
Below. Oh, you better do one minus.
0.068.
Beautiful, and then double it.
0.0136.
0.0136, yeah.
Nice.
So the p-value would be 0.0136. Just in case. Well, alpha was 0.01, right? P-value is bigger than that. So that's another way I can see if I fail to reach up. My p-value has to be smaller than alpha in order for me to reach up. So this kind of gives me information about what strength of a test I would have passed. All right, so I'll tell you what. I'm going to worry about the back of that until later. That doesn't mean we're done with hypothesis, so don't get too excited. So, in the same chapter, we have hypotheses tests for percentages. There's going to be a few things that change, obviously, then, but the 5 steps are fundamentally the same. But if I have a test about a percentage, for example, if I said, test the claim, no Jesus, test the claim that less than 40% of students like hypothesis test. Hypo test. Yes.
Question on the p-value. So
Sure.
if it's 2 tails, how do you, to get the 0.0136, they
You-
subtracted what they got from the z value, which was 0.9932, and they subtracted 1, they doubled it, that's how they got it. But how
Yep.
do you know when to subtract the 1 and when not to if it's
Okay.
2 tails?
This idea is the same it has been since the first day I gave you the z-score chart. P-value is related to the area in the tail or tails. You guys cool with that? Alpha is the area of the tail of the rejection region z-score. P-value is the area in the tail or tails of my z-score. So they fundamentally measure the same thing. If I want an area up here, I already know I'm going to have to do 1 minus what I look up. That hasn't changed. So whenever you learn something new, you have to identify for yourself what part of that is still the same as always. Nothing is ever brand new in mathematics. We build on stuff we know. This one little thing, p-value, new word. What's the reference? Old idea. Area up here in the tail. So if it's up here, I know I'm gonna have to do 1 minus. Don't memorize that shit. Draw the picture and you know if you have to do 1 minus or not. Or memorize that. I can't stop you from doing that. Right? It's just, you only have so much brain space. All right. Test the claim that less than 40% of students like I can't even talk. You're all like, you gotta stop, Jeff. I think it's it for today. No, hi. What's the claim? Can you write it in mathish for me? Not elvish. Speak friend and enter.
That's a like hypothesis.
Yes. The 40% of students like hypothesis tests.
Oh, okay.
I just put hypo.
No, we were talking about the like. Different instance.
All right. Can somebody just tell me what's the claim in math? What's the claim? Something less than or greater than or something? Huh? Nope. Are we talking about means? No, we're not talking about means, right? We're talking about percentages. So what letter am I going to use? P. P. No. So, what does P mean versus P hat? P is percentage of a population. P hat is percentage of percent. So what am I going to do? I have a claim about the population. How am I going to test it? I'm going to take a sample and find P hat to test it. What do I do with means hypothesis tests like we're just doing? I have a claim about mu. And then I take a sample and get X bar to test it. Holy shit, it's the same thing. It's just a different letter because now I'm talking about percentages, not means. I can't use that same letter. So what is it now? P less than? Try again. Yes? There it is. Right? Because we know the minute I write that shit down, I'm going to start working with it, I better make it a number, not this made up thing. You with me? I know on some level everything's made up. Symbol for 4, anyway, we're not going to get that to you. Percentages are not real numbers. They're a way to represent numbers that make it easier to think about. So which one would that be?
It's the high. It's the high.
It's the high because it doesn't have a equal sign. So, do you see how the only change in the first step then is the symbol you use? Because you're not talking about means now. All right. Well, what about, and then the second step is going to be different too, because the second step is, can I use z-scores? not sure if you guys have noticed that you never use a t-score with the p. There's not even a confidence interval formula with p and t in it. There's 2 x-bar formulas and 1 p-hat. Right? But what do I check to see if an NPQ problem is normal? We did it earlier. Yeah. And P and Q have to be greater than equal to 5, right? Okay. We're not really doing hypothesis test, by the way, right now. We're just talking about what the changes would be. The first step, use the right letter. Second step, use the right test. But the second step is still the same idea. Is it normal enough? I just have a different test I have to apply. Here comes this next step. Is going to based on this thing I wrote a long time ago. The third step doesn't change worth shit. I'm going to give you an alpha. You're going to look it up. You're going to get the rejection region. That doesn't change at all. The fourth step, I cannot use this formula now because it's loaded with means and standard deviation. That doesn't have a damn thing to do with percentages, right? That's right, Jeff. Okay. I'm not talking about means. I don't get a standard deviation. I have to have something with percentages in it. But what did I claim the Z-star formula will always be? My data. All right, if we go take a sample and we get a percentage, what's the symbol for that? p-hat. My data minus the supposed thing. And now I've got to divide by the spread. Oh, shit. But here's what's cool. The reason I wrote these down, where's the spread in this statement? Where's the standard deviation in this statement? Not above. This whole thing, right? This is the, okay. This is the standard deviation, right? So therefore for NPQ problems, if you look right above that, what's in that same place? What acts like the spread? This, yeah, so that's what's going to go right here. Let's see if you see the difference.
So it's not p-hat.
Good. Why not? Because I only use p-hat if I don't know p. But I know p. On the confidence intervals, we were constructing an interval for some unknown p, some unknown population percentage. That's what p means. Are you with me so far? What do confidence intervals do? Construct intervals for population information. We don't have a clue what the shit they are. Hypothesis test. The first thing we do is assume that is the real number. So we know what the hell p is. I'm not going to use p-hat then. P-hat is an estimate. I know what p is. 0.4. Yes?
Won't you always know what p is if you're comparing like two claims? Like
I will always know what p is in the hypothesis test because I'm going to assume that it is the number I'm given. Yes.
yeah, okay.
In a confidence interval, I have a clue what the hell p is.
So you would never use like square root of p-hat, q-hat?
Of course not. Yeah. Yes.
You said it's 0.4, but isn't that technically more than 5? Or is it like
Help me. So, what do we check to make sure it's at least 5? Not p. P can never be greater than or equal to 5. Holy shit. Right? The biggest p could be is 1. What do I check to make sure it's greater or equal to 5? I've got it. Don't I have it written? NP. NQ. I didn't say what N was because I'm not really doing a test. I'm just talking about what will change. So the 5 steps, the idea behind the 5 steps don't change. How do I write what I'm talking about? I gotta use the right symbol. How do I know if it's normal? Oh shit, I gotta use the right test. Because I'm talking about means now. How do I find the Z-star? Okay, I need a formula that's got percentages in it. I better use the right formula. But the idea behind every single step doesn't change. All right. So I want to say you're gonna love this next announcement. I think so. Our next Let me make sure I got this straight.
2 Tuesdays away.
Yeah, our next test is,
Not next Tuesday, the Tuesday after.
yeah, the Tuesday after. So let's have a quiz.
Next Thursday.
No, it can't be Thursday because then I can't get it back to you in time for the test. Yeah, so what's gonna be
This
Tuesday? Yeah.
Could it be a group? Actually, no, it'll be a group.
There'll be one hypo test about the mean. Yeah, another quiz. You're welcome, by the way. You want more grades? I'm gonna do for you what's good. And I don't care how much you think it's bad, I'm gonna do it anyway. There you go. So get ready for that shit.
It's gonna be like
It's gonna be one hypothesis test. I'm gonna have all the steps up there.
Just one.
One hypothesis test about a mean, not about a percentage. I'm gonna have all the steps on there.
So percentage.
You can do it. Next test, hell yeah.
I have that handout, not that one, I didn't look at it.
So you do the dicer?
No.
So just do the dicer. As a
It's like the C like format of it.
so just don't flip back to this side, try to do the right side.
Yeah.
Yeah, that's true.
Yeah.
For this one, we use the other support, but for this equation,
Which one's the one? It's HO. So I'm gonna use this language. Okay. The one we just did, which one? No. So you got your flavor though. That's the problem. We believe the average has changed. We believe we not equal. That's why we use the H1 language.
So is it just
Yeah, it's just on hypothesis for the mean.
so no,
The one we've done.
no percentage?
No percentage. We haven't done an example of that yet. So.
Okay.
Yeah. But people make more.
So the first 45 minutes of the class is just a presentation about some random
Oh,
case.
word.
I don't want this.
I don't want either. I know. Carry it around.
None of us want it. Oh, me too. This is actually.
Well, there's that other side of that one that we didn't do. That we'll probably do next time. So yeah, we did that one about birth, but we didn't do the other side. Do you have that?
Oh, yeah, I
You
have
must
that.
have.
Yeah.
So we didn't do that side, right? Alright. So there's some practice. And then of course you got homework problems. Do for practice, yeah.
Thank you.
Sure.